we discussed negative remainder concept. Negative remainder concept. We did the problems based on this one. We did the problems based on this one. Now see the sixth one. Some 2 or 3 questions I will do a repeat. Remainder 1. 25 power 25 divided by 9. 9 3s are 27. So minus 2 power 25 divided by 9. So this is minus remainder of 2 power 25 divided by 9. Which power of 2? When divided by 9, I will get plus 1 or minus 1. So 2 cube power 8 into 2 power 1 divided by 9. 8 by 9. 8 by 9 is minus 1. Minus 1 power even is plus 1. So minus 2. Negative remainder minus 2. Positive remainder will be 7. Positive remainder will be 7. 9 3s are 27 minus 2. Minus 2 power 25 is minus is out. 2 power 25 by 9. Which power of 2 when divided by 9 I will get plus 1 or minus 1. 2 cube power 8 into 2 power 1 by 9. 8 by 9 is minus 1. Minus 1 power even is plus 1. So it is 2. Minus 2 positive remainder is 7. This we have solved it yesterday. These 2 questions we solved it yesterday. These also we solved it yesterday. These also we solved it yesterday. This question also we solved it yesterday. These also we solved it yesterday. Here one important key point which we discussed. A power n plus b power n is divisible by a plus b if n is an odd number. We used this concept. 12th also we discussed. These also we solved it yesterday. 14th. This is a previous year competitive exam question. So I will revise it. 30 power 40 divided by 17. 17 2s are 34. Minus 4. Minus 4 power 40 divided by 17. Minus power even is plus. So this will become 4 power 40 divided by 17. Which power of 4 when divided by 17? I will get plus 1 or minus 1. 4 square power 20 divided by 17. 16 by 17 is minus 1. Minus 1 power even is plus 1. Minus 1 power even is plus 1. Again I am repeating. 17 2s are 34. Minus 4 power 40. Minus power even is plus. 4 power 40 divided by 17. 4 square power 20 divided by 17. 16 by 17 is minus 1. Minus 1 power even is plus 1. 14th also we solved. Now, if you see 15th and 16th. 15th also yesterday we solved. 16th, please put a star mark. 15th and 16th are exam original questions. So I will solve these 15 and 16. Then we will get into the next level. Now 15th, if you see, this is nothing but a remainder of, if I divide by 7, 7 7s are 49, 65, 7 9s are 63, 25, 7 3s are 21, which is 4. 4 power 2, 2, 2, 2, 2, plus 7 4 2s divided by 7. 7 3s are 21, 12. 7 1s are 7, 52. 7 7s are 49, which is 3. 3 power 5, 5, 5, 5, 5 divided by 7. Divided by 7. So this can be written as a remainder of 4 square power 1111 plus 3 power 5 power 1111 divided by 7. Divided by 7. Already we discussed a concept. A power n plus b power n is divisible by a plus b if n is an odd number. If n is an odd number. So this is nothing but 4 square is 16. 3 power 4 is 243. 243 plus 16 is 259. 259 is divisible by 7, which is 7 into 37, which is 7 into 37. So answer for this question is 0. Answer for this question is 0. Again I am explaining. 4 5s divided by 7, 7 sevens are 49, 65, 7 nines are 63, 25, 7 threes are 21. So this is 4. Here it is 7 threes are 21, 12, 7 ones are 752, 7 sevens are 49, 3. 4 square power 4 ones plus 3 power 5 power 4 ones. 4 square is nothing but 16. 3 power 5 is nothing but 243. 16 plus 243, which is 251, 9. 259 is divisible by 7. Very, very important question, sir. Answer for this question is 7 into 37 is divisible by 259. So answer is 0. Answer is 0. I hope idea is clear, right? 16th one, answer is 0. 15th one. 15th one, 15th one, 16th one. Write down the positive reminders when 4 5 is divided by 7 and 4 2 is divided by 7. You will get the answer. 15th one. Reminder 1. Reminder 1. 7 power 7 power 7. 7 power 7 power 7 divided by 9. 9 ones are 9. Negative remainder is 2. So it is 2 power 7 power 7 divided by 9. We discussed yesterday which power of 2 when divided by 9 I will get plus 1 or minus 1. 2 power 6 divided by 9 is 1. So divide this number with this number. If I divide it, 7 power 7 divided by 6. 6 ones are 6. Positive remainder is 1. So 7 power 7 is dividend is divisor into quotient plus remainder. So here it is remainder of 2 power 6k plus 1 divided by 9. So these are nothing but minus 2. Positive remainder is 7. Positive remainder is 7. I am using negative remainder concept here. I am using negative remainder concept here. 9 ones are 9. Negative remainder is minus 2. Minus power odd. Minus is taken out. 2 power 7 power 7 divided by 9. Which power of 2 when divided by? Which power of 2 when divided by 9 will give you 1? 2 power 6 divided by 9 is 1. Divide the power with this power. 7 power 7 divided by 6. 6 ones are 6. Positive remainder is 1. Dividend is divisor into quotient plus remainder. So it is remainder of 2 power 6 plus 1 divided by 9. Minus 2. Positive remainder is 7. Positive remainder is minus 2. Negative remainder minus 2, positive remainder 7. I hope the idea is clear here. Now we will see what is the drawback of negative remainder, why we are going for another theorem. I hope this is clear. Kindly reply it in the live chat if these two questions are clear to you. We just did a revision of entire negative remainder concept. I hope it is clear. Kindly reply in the live chat if negative reminders is crystal clear to you. If it is clear to you, then I will get into another theorem. Is it clear to you? Now see here. Now negative remainder drawback. Negative remainder drawback. Negative remainder drawback. What is the drawback of negative remainder? What is the drawback of negative remainder? Suppose if the question is remainder of 6 power 84 divided by 49. 6 power 84 divided by 49. If this question is there, the entire idea is to find which power of numerator when I divide by denominator I will get plus 1 or minus 1. Which power of numerator when divided by denominator I will get plus 1 or minus 1. So trying to find out which power of 6. Which power of 6 when divided by 49 will give you plus 1 or minus 1? How to find out these value of x in fast? X value fast. X value fast. Right? Finding out which value, which power of 6 when divided by 49 will give you plus 1 or minus 1. 6 square is 36. 6 cube is 216. So finding out which power of 6 when divided by 49, whether it is plus 1 or minus 1, is extremely difficult to us. That is the reason negative remainder. By using negative remainder, we might not get few problems direct answer first. Few problems direct answer first. That's exactly the reason we are going into Euler's theorem application. Please write down. Which power of 6 when divided by 49? Determining which power of 6 when divided by 49 is plus 1 or minus 1 is difficult. So how to find out the value of x? There is a famous mathematician who has given a theorem. That theorem is Euler's theorem. Euler's theorem. Euler's theorem. When this theorem is used when the denominator is a composite number. When the denominator is a composite number. When the denominator is a composite number, you can use this theorem. What does that theorem states? Theorem states a power quotient of n. I will explain this concept neatly. A power quotient of n divided by n is 1. A power quotient of n divided by n is 1, where a and n are co-prime to each other. What do you mean by co-prime to each other? HCF of numerator base to the denominator should be 1. What is phi of n? Phi of n is the quotient function of n. Quotient function of n. I will explain in detail what is the quotient function of n. First, write down this Euler's theorem. What is Euler's theorem? Euler's theorem is used when the denominator is a composite number. If the denominator is a composite number, you can use Euler's theorem. What does that theorem states? Theorem says that a power phi of n divided by n, it is 1. A power phi of n divided by n, it is 1. A and n should be co-prime to each other. A and n should be co-prime to each other, and denominator is a composite number. Now, quotient function. What is this quotient function? Please write down side heading quotient function. Quotient function. Quotient function. Phi of n is nothing but the quotient function of n. Once we understand quotient function of n, then this process becomes very, very easy. Now let us define what is the quotient function of n. Phi of n. In some textbooks, they write it as a tau of n. Tau is a Greek alphabet. Tau stands for quotient function of n. These are nothing but number of natural numbers. Number of natural numbers. Number of natural numbers less than or equivalent to n and co-prime to n. Number of natural numbers less than or equivalent to n and co-prime to n. We will see with an example. Quotient function of n is the number of natural numbers less than or equivalent to n and co-prime to n. Number of natural numbers less than or equivalent to n and co-prime to n. That is called the quotient function of n. Examples. 5 examples, it should be clear to you. 5 examples, it should be clear to you. Find the value of first question, quotient of 20. Find the value of quotient of 20. Listen carefully. Step number 1. Take the number 20. Write down it as power of prime bases, which is 2 square into 5 power 1. 2 square into 5 power 1. So write the number as a power of prime bases P1 power A into P2 power B into P3 power C. Right? So quotient of n. I will give a proof in the next slide. Please write down n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3. 1 minus 1 by P1, 1 by P2, 1 by P3. Please write down this. I will give a proof. I will give a proof for this in the next slide. Any composite number is there. Write it down as a power of composite prime numbers. P1 power A, P2 power B, P3 power C. Quotient of n is n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3. Just substitution we will do here. So this is nothing but 20 into 1 minus 1 by 2, 1 minus 1 by 5. So here it is 20 into 1 by 2 into 4 by 5. 10 2s are 20. So 2 4s are 8. Answer for the first question is 8. But the question is, sir, I cannot remember these notation. You don't need to remember these notation. There is a way in which directly you can write it. Quotient of n is n into 1 minus 1 by A, 1 minus 1 by 1 minus 1 by P1, 1 minus 1 by, sorry, it is A. 1 minus, sorry, it is P1 only. 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by 3. There is a confusion in previous textbooks. They will write it as ABC. So that's the reason. What are P1, P2 and P3? P1, P2 and P3 are prime numbers. P1, P2 and P3 are prime numbers. P1, P2 and P3 are prime numbers. We will do one more question. We will do one more question, then we will see the proof. In fact, we will do 2 questions, then we will see the proof. Next, 2 examples. Find the value of, I will tell you why am I doing these 2 questions. Once the problem starts, then you will understand. Quotient of 49. One is a non-perfect square, another is a perfect square. 100 is nothing but 2 square into 5 square. So, 2 square into 5 square. Answer is n into 1 minus 1 by P1, 1 by 2, n into 1 minus 1 by P2. So, these 10 cancel. So, answer for this question is 40. Answer for this question is 40. Right? So, the powers, there is no significance. There is no significance. There is no significance on the power of prime bases. There is no significance on the power of prime bases. Whatever the prime bases are there, please do not need to worry. There is no significance on the power of prime bases. These are nothing but 49 is 7 square. So, 49 into 1 minus 1 by 7, which is 6 by 7. So, answer for this question is 42. Answer for this question is 42. 3 examples to find out the quotient function of n. But we have not seen how come that quotient function became n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3. Please write down this. Next 2-3 slides are extremely important to understand the definition of quotient function. Just an application. Now write down the next question. HCF of A comma 72 equivalent to 1. A is less than or equivalent to 72. How many values A can take? How many values A can take or A will take? See this question. HCF of A comma 72 equivalent to 1. A less than or equivalent to 72. How many values A can take? This is nothing but 72 is 2 cube into 3 square. 2 cube into 3 square equivalent to 1. A less than or equivalent to 72. Am I right? Am I right? Now, if HCF of these two numbers is 1, can I say that these two numbers are co-prime to each other? These two numbers are co-prime to each other. If these two numbers are co-prime to each other, can I also say that the question is like this: how many natural numbers? How many natural numbers? How many natural numbers less than or equivalent to 72 are not divisible by 2 and 3? Are not divisible by 2 and 3. Can I also write this statement as like this? How many natural numbers less than or equivalent to 72 are not divisible? Why the statement became like this? Why? Because HCF of these two numbers is 1. If HCF of these two numbers is 1, that means A cannot be divisible by 2, A cannot be divisible by 3. Are you all with me? Right? These, if two numbers HCF is 1, that means that two numbers are co-prime to each other. If they are co-prime to each other, that means A cannot be divisible by 2 and A cannot be divisible by 3. Now, see carefully to this explanation. See carefully to this explanation. Suppose total there are 72 natural numbers are there. 1, 2, 3 and so on up to 72. Out of 72 natural numbers, A should not be, first A should not be divisible by 2. A should not be divisible by 2. For every two consecutive numbers, you take any two consecutive natural numbers, 1, 2. 2 is divisible by 2. 9, 10. 10 is divisible by 2. 14, 15. 14 is divisible by 2. 71, 72. One number is divisible by 2. That means out of every two consecutive natural numbers, one number is divisible by 2. One number is not divisible by 2. I hope it is clear. Next it is not divisible by 3. Not divisible by 3 means for every three consecutive natural numbers, 4, 5, 6. 6 is divisible by 3. 8, 9, 10. 9 is divisible by 3. Out of every three consecutive numbers, one number is divisible by 3, but not divisible means total minus numbers divisible. Total minus numbers divisible. So 72 into 1 by 2 into 2 by 3. Answer is 24. Answer is 24. If two numbers HCF is 1, if two numbers HCF is 1, that means two numbers are co-prime to each other. Two numbers are co-prime to each other. Co-prime number means A should not be divisible by 2. A should not be divisible by 3. A should not be divisible by 2. A should not be divisible by 3. Because it is less than or equivalent to 72. For every 72 numbers, if they are written in the serial order, every two consecutive numbers, one number is divisible by 2. One number is divisible by 2. How many are not divisible by 2? Total minus numbers which are divisible will give you the numbers which are not divisible. 1 minus 1 by 2. Out of three consecutive numbers, one number is divisible by 3. How many are not divisible by 3? A comma 360. A comma 360 equivalent to 1. A less than or equivalent to 360. A less than or equivalent to 360. How many values A will take? how many values A will take. HCF of A comma 360 equivalent to 1. How many values A will take? Again see here. HCF of 360 is nothing but, if I simplify it, 2 180s are 360, 2 90s are 180, 3 30s are 90, 3 10s are 30, 2 5s are 10. 2 came how many times? 3 times. So HCF of 2 cube into 3 came how many times? 2 times. 3 square into 5 power 1 equivalent to 1. HCF of A comma 2 cube into 3 square into 5 power 1. You don't need to do anything. If I write first 360 natural numbers, for every two consecutive numbers, one number is divisible. Total how many are not divisible? 1 minus 1 by 2. For every three consecutive numbers, one number is divisible by 3. How many are not divisible? 1 minus 1 by 3. For every 5 consecutive numbers, one number is divisible. How many are not divisible? 1 minus 1 by 5. 1 minus 1 by 5. Quotient function. What do you mean by quotient function? Quotient function is number of natural numbers less than or equivalent to n which are coprime to n. Coprime numbers means numbers which are not divisible by the prime basis. 360 into 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5. So answer for this question is 360 into 1 by 2 into 2 by 3 into 4 by 5. 2 2 cancel. 15 24s are 24 4s are 96. 24 4s are 96. Why this 1 minus came into picture? 1 minus 1 by 2. Out of every two consecutive natural numbers, one number is divisible. How many are not divisible? 1 minus 1 by 2. 1 minus 1 by 3. 1 minus 1 by 5. 360 into 1 by 2 into 2 by 3 into 4 by 5. Third example, it will be crystal clear to you, sir. By the time the class is over, you will not get a single doubt. In case if any student is feeling sleepy watching my class, don't sleep. Stand up, go and wash your face. Ask your parents to give a cup of strong tea to you. Sit. Just don't give up at this point of a time. It's very easy to switch off the mobile and go for sleep. Out of 195 will do that. You belong to that other 5. Just push yourself to that non-comfort zone for few more minutes. Automatically this will become a habit. Just don't give it up. Right? Next one. 2 questions. HCF of A comma 30 equivalent to 1. A less than or equivalent to 30. How many values A will take? 30 is nothing but HCF of A comma 2 into 3 into 5 equivalent to 1. So this will become, out of 30 natural numbers, for every 2 natural numbers, one number is divisible. Remaining is 1 minus 1 by 2. Out of every 3 consecutive natural numbers, one number is divisible. Remaining is 1 minus 1 by 3. Out of every 5 consecutive natural numbers, one number is divisible. Remaining is 1 minus 1 by 5. So 30 into 1 by 2 into 2 by 3 into 4 by 5. 15 2s are 30 eliminated. Answer for this question is 8. Answer for this question is 8. Are these examples clear to you? Kindly reply it in the live chat if this concept is clear to you. If this concept is clear to you, kindly reply it so that I will discuss one more problem. Is this clear to you? Is this clear to you? Everybody kindly reply if it is clear to you. If it is clear to you, then we will take one more question. Then we will solve Euler's theorem. Now it will be easy. How many natural numbers less than or equivalent to 360? First question, are divisible by 2, 3 and 5. How many natural numbers less than or equivalent to 360 are divisible by 2, 3 and 5? 360 is nothing but 2 cube into 3 square into 5 power 1. Divisible by 2, 3, 5. For every 360 consecutive natural numbers, for every 2 numbers, one number is divisible. Question is not divisible. Question is divisible. For every 3 consecutive numbers, one number is divisible. For every 5 consecutive numbers, one number is divisible. Only if it is not divisible, I will do 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5. Question is divisible. For every 2, one number is divisible. For every 3, one number is divisible. For every 5, one number is divisible. 6 5s are 30. 360 goes 12 times in 30. So the first one answer is 12. Second question, divisible by 2. But not by 3 comma 5. Divisible by 2 but not by 3 comma 5. It is divisible by 2 but not by 3 comma 5. Out of every 3 consecutive natural numbers, for every 2, one number is divisible by 2. But not for every 3 numbers, one number it is divisible. Not means 1 minus 1 by 3. For every 5 consecutive natural numbers, one number it is divisible, but not means 1 minus 1 by 5. So this is 360 into 1 by 2 into 2 by 3 into 4 by 5. I hope the idea is clear. Not means put 1 minus. If there is no not exact, for every 2 numbers, one number it is divisible. For every 3 numbers, one number it is divisible. Not means 1 minus 1 by 3. For every 5 consecutive numbers, one number it is divisible. Not means 1 minus 1 by 5. So answer is 30. 2s are 12, 8s are 96. What is a totient function? What are all the applications of totient function? Now, we will solve Euler theorem application. I hope the idea is clear. Euler theorem application. Problems based on reminders. Euler's theorem application. We will write down Euler's theorem here. Euler's theorem. The theorem states remainder of a power x divided by n, it is 1. A and n should be co-prime to each other. N is a composite number. Euler's theorem is used when the denominator is a composite number. So this is, if it is p1 power x1, p2 power x2 into p3 power x3 it is nothing but quotient of n is n into 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3. So first thing what we will do is, this is Euler's theorem. We will execute it. 5 power 37 by 63. 63 is nothing but 3 square into 7 power 1. 9 sevens are 63. So 5 of 63 is n into 1 minus 1 by 3. Next one, 1 minus 1 by P2. So these are nothing but 63. 63 into 2 by 3 into 6 by 7. 2 by 3 into 6 by 7. 21 3s are 63. 6 2s are 12. 12 3s are 36. 12 3s are 36. First one, this is nothing but 5 power 36 into 5 power 1 divided by 63. 5 power 36 by 63 is 1. So answer for the first question is 5. Answer for the first question is 5. Answer for the first question is 5. Now, Arun says, sir, 96 numbers are divisible by 2 but not by 3, 5. I just gave a basics to a quotient function. In the HCF class, I will discuss in detail by using a Venn diagram concept. In case if you want that clarification, 96 numbers which are divisible by 2. In the 96 consecutive natural numbers, how many are divisible by 2? Any number which is divisible by 2 is a even number. So there are 48 numbers. There are 48 numbers which are divisible by 2. In that 48 numbers which are not divisible by 3, 48 into 1 minus 1 by 3, 48 into 2 by 3. There are in that even numbers which are not divisible by 5, 48 into, right, 1 minus 1 by 5. We will discuss in detail once we discuss Venn diagram concept. I just gave Euler's theorem, few examples only. Few examples. We will also discuss Venn diagram concept in the evening so that you will understand it. Just basic understanding of Euler theorem. 1-2 examples I will discuss. I will not get into that Venn diagram question. It might result a little confusion. When I keep the heading as Venn diagram, I will take up your question. This I will keep it as of now with me. 2 power 100 divided by 153. 153 is nothing but 9 into 17. So, quotient function of 153 is n into 1 minus 1 by a, 1 minus 1 by 17, 16 by 17, 51 3s are 153, 3 2s are 6, 6 16s are 96. So, this is nothing but 2 power 96 into 2 power 4 divided by 153. This is 1. 16 by 153 is 16. 16 by 153 is 16. First one, how much we got answer? 5 power 36 into 5 power 1 divided by 63. This is 1. 1 5s are 5. First two problems, see here, in the negative remainder, determining which power of 2 when divided by 153, that becomes a little complicated. Now it becomes little easy. You can determine which power of numerator when divided by denominator is 1 or 1 by using Euler's quotient function. Euler's quotient function will help us in determining numerator power x divided by denominator is 1. How to determine these x value when the denominator is a composite number? That is the utility of quotient function. Numerator power x divided by denominator, remainder is 1. Finding out, right, the value of x, can be solved very easily by using quotient function, right? Now, third one. Slowly we will increase the level of difficulty. First we will solve a lot of practice problems. 25 is 5 square. So quotient of 25 is 25 into 1 minus 1 by 5, which is 4 by 5, which is nothing but 20. So this is nothing but remainder of 3 power 20 power 4 divided by 25. 3 power 20 divided by 25. Answer is 1. 1 power any number is 1. Rajat, I will discuss that doubt also. Shiva, yes, you have understood it right. 3 power 20 power 4 divided by 25. 1 power any number, it is 1. Fourth one. First we will see the concept. Last 3 digits for any number, is nothing but the remainder when I divide a number by 1000. Last 3 digits for any number is the remainder when I divide a number by 1000. You divide a number by 1000, I will get the last 2 digits. 1, 2, 3, 4. 1, 2, 3, 4. So the last 3 digits will be divided by 1000. 1, 2, 3, 4 divided by 1000. 1000 ones are 1000. So this is 234. Last 3 digits for any number is the remainder when you divide a number by 1000. When you divide a number by 1000, you will get the last 3 digits. So this question is nothing but remainder when you divide a number by 1000. This question is nothing but remainder when you divide a number by 1000. So this is nothing but 1000 is 125 into 8. 125 is 5 cube. 8 is 2 cube. So this is nothing but 57 power 802 divided by 1000. So 1000 quotient function is n into 1 minus 1 by a, 4 by 5, 1 minus 1 by 2, which is nothing but 400. So here it is remainder of 57 power 400 power 2 into 57 square divided by 1000. So this is 1. 57 square is 3249. 3249 divided by 1000. 1000 threes are 3000. Remainder is 249. Last 3 digits of any number is the remainder when you divide a number by 1000. 1000 is 125 into 8. 125 into 8. 5 cube into 2 cube. So 1000 into 1 minus 1 by 5, 1 minus 1 by 2, 400. 400 twos are 800. Remaining is 57 square. 57 square is 3249 divided by 1000. 1000 threes are 3000. Remainder is 249. I hope it is clear. 25 is 5 square. So quotient of 25 is 25 into 1 minus 1 by 5. It is 20. So this is nothing but remainder of 3 power 20 power 4 divided by 25, which is 1, which we solved it already. 4 problems. I hope you all are understanding how to use Euler's theorem. Please kindly reply in the live chat if it is clear to you, so that we will get into the next level. Euler's theorem application. Is it clear to you? Euler's theorem is used when the denominator is a composite number. Euler's theorem is used when the denominator is a composite number. If the denominator is a composite number, Euler's theorem is used to find which power of numerator when divided by denominator, I will get +1. Now I will increase the level of difficulty. Kindly reply it in the live chat if it is clear to you. Everybody kindly reply. Everybody kindly reply. Right. Now, next question. 6 power, this is the doubt which we took it. 6 power 84 divided by 49. 49 is 7 square. So, quotient function of 49 is 49 into 1 minus 1 by 7. So, it is 6 sevens are 42. So, this is nothing but 6 power of 42 into 2 divided by 49. 1 divided by 49. 1.